Welcome, everybody. Wow, that was great. The best start yet. Today we're talking about convergent and divergent series. So we technically these are just going to be kind of new-ish words for concepts that we maybe already partially understand. But if I have a list, let's see, what do I want to write? If I have a list, a sequence, whose partial sums have a limit, the series is convergent. Or the series converges, maybe I'll say. All right, my infinitely many things approach, right? There's some approaches a specific number because the limit exists. All right? Well, I guess I'll just say, if not, the series diverges. So, diverges, converges. So if it has a limit, it converges towards a single point, I guess you could say. And if it does not, then it diverges where it's just trailing off to infinity. And yeah, and we won't be able to catch up. So, so it turns out, let's see, let me paste this little thing, blam. And that's kind of what this says here. So maybe it doesn't make sense to rewrite this, but we have it nonetheless. It says, if an infinite series has a sum or limit, the series is convergent. If a series is not convergent, it is divergent. Perfect, right? Same idea, right? Basic idea going on there. So let's do an example of this. And let's determine whether each is convergent. All right, determine whether the series is convergent. Or divergent. Or divergent. Whenever I see the word whether, I'm very particular about pronouncing the first H in it, the second letter of the first H. When I took a course in college, like public speaking or speech class or something like that, and the professor had us all memorize particular tongue twisters, and you'd have to say them 3 times fast in front of the whole class, and if you got a single syllable wrong, you'd have to go sit down and then do it again later. It's pretty good. And the tongue twister we had about that was, whether the weather be hot or whether the weather be cold, we'll be together, whatever the weather, whether we like it or not, was the tongue twister.
Oh my God.
So whenever I see the word whether, I say it like that.
And you have to say that every day?
No, I don't use whether often enough.
No, I mean, like when you were in college.
No, I didn't say it every day. It was just as one of the things that he had us do. And then once you said it 3 times, then you didn't have to do it anymore. You got your little check in the book. It's pretty good. So we also had to do the rubber baby buggy bumpers one, and I forget the other ones.
Rubber baby buggy bumpers, rubber baby buggy bumpers, rubber baby bunky.
Yeah.
Oh my God, I said bunky.
Yeah, that's what usually happens. But yeah, it was interesting. Oh, that sounds terrible.
That was impossible. And toy boat.
Negative 1/2 plus 1/4 minus 1/8 plus 1/16 minus ...
Hang on, minus 1/8.
So let us determine whether this series is convergent or divergent. So in order to answer this question now, you'd have to know whether or not it has whether or not it has a limit. And in order to do that, I guess, well, first of all, what type of series is this? Currently, we only know of two specific types, arithmetic or geometric.
Geometric.
This is geometric.
R is negative.
1/2.
So this is geo. Yep, you guys told me correctly that r is negative. What is a sub 1? That's not as important to us. Negative 1/2. And what is r? Oh, it appears also to be negative 1/2. And now, how do I know whether or not this geometric series has a limit? Yeah, I could find it, or
If r is less than, or is it less than 1?
less than 1.
Equal to 1 wouldn't do very much.
No, it wouldn't be a very entertaining series.
And it's some
It
wouldn't
would
be
be-
calculatable because
Yeah.
it would go on forever.
Also true. Good call. Yes.
So it must.
So the absolute value is less. Absolute value of r is less than 1. Therefore, it has a limit, and therefore the series is convergent.
Because I missed this lesson, I thought it said magnitude of R.
Yeah. Back with vectors and whatnot. Whatnot. So let's see. How about this? This series. How about this? 2 plus 4 plus 8 plus 16. Let's see. Arithmetic, geometric.
Geometric.
Geo. What's R? 2. Because I'm adding 2 each time?
No, it's multiplying.
No, because I'm multiplying by 2. Silly Mr. Waddy. So abs R is greater than 1. Therefore, it is divergent. And I think you guys could have looked at this and realized that list is adding to infinity. All right? You could have just glanced at it and figured that out. How about this one? What if I've got 10 plus 8.5 plus 7 plus 5.5 plus ... ellipsis. It's arithmetic. But it's getting smaller. Do you think it adds to a finite number?
No. It could be negative infinity.
Yeah, because this list, even though it's getting smaller, it's subtracting, or it's adding negative 1.5 repeatedly, right? And eventually this list is going to get negative, and eventually the list itself is going to approach negative infinity, and adding infinitely many things that are infinitely negative
So
is
basically,
going to equal negative infinity.
the only way an arithmetic series can be calculatable is if it goes in both directions infinitely.
And even then that would be difficult. I don't think it would work out. I think pretty much in general, any arithmetic sequence is a no-go. It's going to be divergent. Okay? So I think you guys agree that the ratio of our subsequent terms kind of matters a little bit, right? Like the fact that this term was smaller than that term mattered. The fact that this term being bigger than the previous, you could realize, well, that's kind of growing, right? And it turns out that there is this concept called the ratio test. You wouldn't normally roll that R, but this is how I roll my R. Man, I don't know where did I come from? What is this? So let's see. Let's take a look at this. Ramp.
Oh, do I need to write this down?
I might have you to summarize the very last formula here, but let's read it first. It says the ratio test. Let a sub n and a sub n plus 1 represent two consecutive terms of a series of positive terms. Blah. Suppose the limit as n approaches infinity of the ratio of my n plus 1th term over my nth term exists. All right? And it turns out that r is equal to that limit. Okay? The series is convergent if r is less than 1 and divergent if r is greater than 1. If r equals 1, the test provides no information. So it's inconclusive results when r is equal to 1. So I guess this is the formula that we'd want to write down, just this part, the limit as the limit as n approaches infinity, there we go, of a sub n plus 1, that's a tiny plus 1, all over a sub n. And then there's 3 cases, right? R less than 1, divergent, R greater than 1. Nope, I just lied. R less than 1 is convergent, right? Similar to the R, the common ratio amongst a geometric sequence. If R is greater than 1, it's divergent, and if R equals 1, it's inconclusive. So I would just want to point that out. Inconclusive.
None so
All right. Inconceivable. All right. Classic.
Wait, doesn't they mean the absolute value of R?
Well, they had this additional thing that, assuming that the series of positive terms.
So can I just put?
Nah. Well, we'll
So-
leave it to that stipulation. Oh, man, I'm writing on a slope already. Slopey. Sloppy. Plus 2/4 plus 3/8 plus 4/16 plus ...
One half.
So, take a look at this series and let me know, what would you classify this series as?
The first two terms create 1.
Is it geometric? Well, let's think about R.
It's
Now, these are two different kinds of R's.
metric.
If I found the common ratio, assuming this was geometric between these two, 2/4 is 1/2, so this would be 1/2 over 1/2, which is 1, right? And that doesn't agree if I found R using these two terms, right? Because I would do 3/8
Well, the bottom's doubling.
over 2/4, and I would get, let's see, 3/8 times 4/2, 3/4. So yeah, there's a problem with my R. So it's not geometric. So geo, no.
It's not.
It's not arithmetic either. I think you guys agree. Right, because between the first two terms, since those two terms are identical, would have been adding 0. That also doesn't work, right? So this is like some weird new series for us.
Is it exponential?
No. So what I'm going to need to find is, what is a sub n equal to? And then after I find that, I might be able to figure out what a sub n plus
running out
1.
of room.
Yeah, I am as well here. I'm bordering the edge of my scroll downage. So let's break this up. Sometimes for these patterns, it's easiest to break this up into numerator and denominator. Also, I want to point out, notice that some of these fractions were conveniently not reduced. That won't. Sometimes a sequence may be given to us with previously reduced terms, and then the pattern will be very difficult to recognize. Right? Like if this pattern was 1/2 plus 1/2 plus 3/8 plus 1/4, that would have been way more difficult to see. So sometimes it's actually worth it to have them kind of be in these weird non-reduced fractions, because the pattern might be recognizable if I break it up into two parts, the numerators and the denominators. What is my numerator pattern?
They're adding 1.
Arithmetic.
The numerator appears to be arithmetic, where the nth term, what would the numerator be? Well, if this is a sub 1, then n was 1. If this was a sub 2, then n was 2. If this was a sub 3, then n was 3. So a sub n, the numerator is
N.
just regular old n, right? And what's going on in the pattern of my denominators?
It's
2 to the n.
2 to the n? Yeah, it's doubling each time. Each of these are powers of 2. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. Yeah, so 2 to the n. Okay. I think I agree. So what would the n plus 1th term look like?
N plus 1 over a to the n plus 1.
Over 2 to the n plus 1, right? But yes.
2. Yeah.
And that's a tiny plus 1 for that exponent. I just want to make sure. 2 to the n plus 1, where it's a big plus 1, is very different than micro plus 1. All right, so now I've found these. What does this say I should do? All right, I found these two things. Apparently, I have to find the limit of the ratio of these two things. So I guess that's what we do. Let's do this. So let's find the limit as n approaches infinity.
I'm going to have to go to the other side.
Yep. I might be as well in a moment, so you're just...
n plus 1 over 2 to the n plus 1 all over n over 2 to the n.
Bless you. I'm going to try my best to fit this in here.
Hang on.
So before I take the limit of this, I think I might simplify the fraction itself. It's a stack of frac situation. I get a limit.
The point of writing n or the thing is always instant.
It's not always going to be infinity, though.
It'll never be infinity.
No. But
It'll get changed to close.
eventually we'll have different stuff there. So let's see, I'm going to multiply by the reciprocal of this denominator. But yeah, so far that's what we've got. So I multiply by the reciprocal of the denominator, and is there anything I can do?
Well, you can cancel out
Yeah.
2 to the n and make the bottom term 2.
Yeah, isn't this awesome? Right, using my properties of exponents, right, if I had x squared over x cubed, I would subtract the smaller exponent from the larger. Right, so I've got 2 to the n over 2 to the n plus 1. So this 2 to the n will cancel out with n many of those exponents, leaving just one behind. It's a nice little simplification there.
2 to the 1.
So I'll have n plus 1 over 2 times n.
Over 2 n. N plus 1 over 2 n.
Right. And now how would I find that limit? Oh, you might just know it based on a trick, but let's do this proper. Why not? Limit as n approaches infinity. And now this is kind of like a problem we had 2 lessons ago. I would divide each term by n to the highest degree. What is the highest degree n here?
N.
N. So n over n plus 1 over n all over 2n over n. And I will get... Although you might have, if you're clever, you might already just be able to look at that and know that limit. Let's see, so let's simplify some.
1/2.
So this is 1 plus 1 over n over, these n's cancel out as well, 2. And now take it to the limit. Take it to the limit. Limit as n goes to infinity of 1 is 1. N is going to 1 forever. 1 over n is going to 0.
Decrease forever.
And 2 is going to 2 forever. This limit is 1/2. Whew, my
It
goodness.
isn't going to 0. It's like,
It's approaching.
yeah. It's really close to 0.
But as n goes to infinity, 1 over n is, approaching 0. Sure. So, what does that tell me? R equals 1/2. All of that to find out what?
It's convergent.
Convergent? Because r is less than 1. So the general approach there, I just want to point out, re-summarize. I found my nth term. I found my n plus 1th term. I took the ratio of those, limited it to n approaching infinity. I don't think that's proper language, but whatever. And since that limit was less than 1, I know that it's convergent. Basically, that's telling me each term in the series is getting smaller and smaller and smaller in a way that, unlike my arithmetic one earlier, right, this arithmetic example, even though these were getting smaller and smaller and smaller, they weren't trailing off towards a particular number, where the one in this current one does.
It has no asymptote.
Yeah, this one would be asymptotic eventually. All right. So there's that. I think maybe I should fit one more good example in here. Yeah. We should.
Needs to be done.
Needs to be done. One more. I'll do this one quicker. Quaker. I'll math like a Quaker. Let's see. Example.
Quaker oats.
Quick oats. That's what I had this morning. I mix 1 part quick oats with 1 packet of regular amount of sugar fruit oatmeal, right? And then I mix them, so I figure that's half the sugar of regular oatmeal. And I cook it. And then I put some like low-fat or no-fat vanilla yogurt on top after it's cooked. It's a pretty good combo. Yep, what can I say? There you go. Does that count as a recipe because I combine ingredients? I was just going to say that's like Mr. Waddy's recipe break during the middle of this math video. But is it a recipe just because I combine? I don't know. It's a simple recipe, I'd argue. Yeah.
1 times 2 over 1 times 2. So it's 1 over n plus 1 factorial.
We shall see. I was thinking of using Excel and calculating my grocery list and figuring out the number of calories in each item and the number of percent daily value of each vitamin and everything like that, and then also the cost of each food item. And then whenever I'd figure out my grocery list, I know exactly how many calories I was getting per week or per meal. Pretty good. Per dollar. Yeah, really minimize my stuff. I ended up finding some websites last night about once a month grocery shopping, where these people pre-plan everything, go out once a month, 12 times a year. Pretty interesting. I guess you need a freezer for that, like an extra freezer. Makes sense. So let's see. Looking at this,
Lots of frozen pizzas.
I'd hope they're eating healthier than that. So let's see. Blah. This is not arithmetic or geometric. Nope, it is not. And notice they conveniently gave it to us in this form. What if, actually before I did this, what if this was as ugly as this? 1 over 1 plus a half plus a sixth plus a 24th. Now, I might recognize that pattern because denominators are 1, 2, 6, 24. The next one, I believe, would be 120. Those happen to be factorial numbers. But they conveniently gave it to us in this order, so it was a little bit recognizable to us. So what's my a sub nth term?
1 over n factorial.
1 over n factorial.
1 over n.
Yes, absolutely. The n plus 1th term.
1 over n plus 1. Factorial.
Factorial. So, interessante. So, let's take it to the limit. Man, I need a DJ soundboard over here where I can just play a 3-second clip from that 80s song.
Is that a song?
Yeah.
I'm sure it was on all
Every time I take a limit, I'd play 3 seconds of that song. How great would that be? It'd be amazing. That's what it would
You
be.
get like Mario coins from using gold pieces.
Someday.
Or someone gets it for
So the limit as n goes to infinity of 1 over n plus 1 factorial times the reciprocal of this guy
and factorial.
over 1 or just n
The
factorial?
ones cancel out.
Yes. Yes. Excellent. The ones do cancel out.
That would just
Like
be
two creepy
1 over
hobbit people that are trying to break into an apartment and then ended up fighting each other for both apartments.
1 over n plus 1.
So 1 over n.
No, 1 over n plus 1.
Well, this might not be as obvious unless you're used to some factorial stuff. Maybe I'll write this. You don't have to rewrite this next step. But this is the same as n factorial over... Now, n plus 1 factorial. What is the second term in n plus 1 factorial? Well, yeah, I guess if you're counting from that side, 1 times 2 times 3 times 4 times blah, 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 blah,
Oh,
blah.
the second that'd be
The second from the end, I guess,
n.
would just be n, right? So this would be the same as n plus 1 times
n factorial.
n factorial. Because n factorial means n times n minus 1 times n minus 2 times ... times 3 times 2 times 1. So if I multiplied these two things, that is n plus 1 factorial. Like if I multiplied by an n plus 2 in front of it, now it's n plus 2 factorial. All right. This takes a little bit getting used to that idea. That's why I wanted to make sure I showed you this problem. And now what conveniently cancels out?
n factorials.
Completely.
Wait, really? It's 1 over n plus 1?
Yeah.
Really? I thought it was 1 over n. 7 factorial. If n was 6, then it would be like 6 factorial over 7 factorial, which is
6 factorial.
7.
Exactly, which is n plus 1. You said n
Oh,
Mhm.
now I see.
Very
plus
good.
6. Okay.
So, now you could do some math work on this, or maybe not, because 1 over n plus 1, if I know that 1 over n is going to 0, 1 over n plus 1 is just getting there like one step faster. Right? It's going to 0. 1 faster. Yes. So, what does this tell you about this series? Convergent or divergent, my friends?
Convergent.
Oh, convergent. Yes, sorry.
Absolute value of r.
Wait,
is
that
less
doesn't
than-
make sense. It's increasing infinitely.
Is it? It's getting smaller.
Decreasing in-
Oh, God. Denominators.
Denominators. Classic. Well, anyways, ladies and gentlemen, that's a basic look. And I just want to make sure you realize, I'm not going to do one of those examples right now, but we'll look at one on the homework or classwork, I'm sure, that if r equals 1, we are no closer to finding out whether it's convergent or divergent. And we'll learn some additional tactics in the next video. Thank you. Bye-bye.